Good morning, friends, and welcome to another class. Today, we'll be looking at isotopes. That we'll see if we can remember some of the things we learned earlier on under atoms. I remember very well we said that atoms were the building blocks or the building units of elements. And I remember we drew something like this to represent an element, and we divided it into units, and those units represent, in this case we have four units, so these units are going to represent the four atoms that form the element. Let's make this element hydrogen. What it means is that this element hydrogen has these atoms that are its building unit or its building blocks. Now, it's very important for us to remember that all the atoms in this element should always have the same atomic number. In fact, atomic numbers are the numbers that actually define what elements are. So it is the atomic number that will tell you what kind of element you are dealing with. So if an atom has atomic number of, let's say, 1, you know that it's an hydrogen you are dealing with. If it has atomic number of 20, then you know also that you are dealing with the atom calcium. What it means is that all the atoms within an element should have the same atomic number. So let's do this on another slide. What we're going to do is this. We are going to take three of the atoms in the diagram, this diagram. We'll take three of the atoms from that diagram. So I'll draw a table. So that's the first atom, that's the second atom, that's the third atom. These atoms are the building units of the hydrogen elements. First, we've established that because the atomic numbers determine the elements, these atomic numbers should always be the same. So if hydrogen has atomic number of 1, we write that one as a subscript here. That one should apply to all of the elements that form the hydrogen, sorry, all of the atoms that form the hydrogen elements. Good. We also know that atoms have mass numbers. So, but what happens to the mass numbers? Are the mass numbers also the same? The truth is that the mass numbers can vary. Although atomic numbers strictly they should be the same for all of the atoms that make up the atom element, mass numbers can vary. And in the case of hydrogen, you can have hydrogen with mass number of 1. You can also have hydrogen with mass number of 2. You can have hydrogen with mass number of 3. So you see, we have 3 different hydrogens. But remember, all of these hydrogens, they have the same atomic numbers or the same proton numbers. However, their mass numbers are different. So you have 1 here for the first hydrogen atom, you have 2 here for the second hydrogen atom, and you have 3 here for the third hydrogen atoms. Anytime you have something like this, these atoms are referred to as isotopes. So isotopes simply are atoms of the same element. So first, atoms of the same element. Remember, these atoms should be of the same element. Okay? Then two, these atoms should also have the same atomic numbers. However, their mass numbers are different. So I need you to note this. So atoms of the same element with the same atomic numbers but different mass numbers. These are isotopes. But the point is this: what do you think is what do you think is resulting in this difference in mass numbers? What do you think? Well, because we do not have time, let me quickly run through this. Remember that when we're looking at mass numbers, we said that mass numbers are gotten whenever you add proton numbers or atomic numbers to neutron numbers, right? Good. Now we know that for every atom, the proton number doesn't change for atoms of the same element. So for us to have different numbers, what it means that came from the neutron number. So simply put, it is the neutron number that is different. So the difference in the mass numbers came from the difference in the neutron numbers. So we can also say that isotopes are atoms of the same elements, okay, with the same atomic numbers, but different mass numbers. Sorry, different neutron numbers. It's the same thing. So you need to note this. So it can be with different mass numbers or it can be with different neutron numbers. So that's what isotopes are. So let's quickly look at some of the isotopes, elements that have isotopes. So we can look at some of them. You can have hydrogen, the first one. Hydrogen is one of them. It's an element. Let me use the symbols rather. I think that would help. So hydrogen is one of the elements with isotopes. And the isotopes of hydrogen are, so we have hydrogen 1, another hydrogen, and another hydrogen. Remember, the atomic numbers or proton numbers do not change. It's the same for all of them. So here it's 1, 1, and 1. However, they have different mass numbers. So you have hydrogen 1, you have hydrogen 2, and you have hydrogen 3. So these are all hydrogen atoms of the same element hydrogen with the same atomic numbers 1, 1, 1 at different mass numbers 1, 2, 3, and that difference in mass numbers came from their differences in their neutron numbers. So that's one of the elements with isotopes. Let's try another one. You can have another isotope, boron. Boron is an element that also has isotopes. So you can have boron and another boron. Remember, boron has atomic number of 5, so the 5 will be the same for all of them because isotopes have the same atomic numbers. However, their mass numbers will change. So you can have boron with mass number of 10, you can have boron with mass number of 11. These are all boron atoms found in the element boron. However, they have different mass numbers, but their atomic numbers are the same. You can use another example. Let's take the last example, oxygen. Oxygen, we have oxygen 1, you can have oxygen another one, and the third oxygen. Oxygen has atomic number of 8. Let me write 1 here, 5 here, and 8. That will make sense. Okay, so oxygen has atomic number of 8. So these oxygen atoms will all have atomic number of 8. However, the first isotope of oxygen has a mass number of 16. This one has mass number of 17, and that has mass number of 18. So these are three isotopes of the oxygen element. So I believe you understand what isotopes are. If you are asked to define what they are, isotopes are simply atoms coming from the same element with the same atomic numbers or proton numbers. Remember, atomic numbers are the same as proton numbers, but different mass numbers. Their mass numbers are different. And that is as a result of the difference in their neutron numbers. That's what isotopes are. It's as simple as that. Now, let's look at something very important. Let's see. So let's say, hydrogen, one with the one, this another hydrogen. These are two isotopes of hydrogen. What do they have in common? So, isotopes of the same element. What do these isotopes have in common? So, one, we can say that they have the same proton. Or let's start by saying that they have the same atomic numbers. To be so same atomic numbers. Then of course, if you have the same atomic numbers determine proton numbers. So they should have the same proton numbers, right? That's Then if they have the same proton numbers, remember when we were looking at neutrality of atoms, we said that in a neutral atom, protons are equal in number to electrons. So if they have the same proton number, they should have the same electrons. Now, final one, we've not touched on this, but it's very important for you to note that for elements or for atoms, what determines their chemical properties is the electron. Electrons determines the chemical properties of elements. So if these isotopes have the same number of electrons, what it means is that they would also have the same chemical properties. We'll be looking at how electrons affect chemical properties in another video in the future. So just note this, it's very important. So that's what isotopes of the same elements have in common. But the question is, how different are they? So let's try that one. So we have isotope of the same hydrogen. So we have another one here. So these are two isotopes. What do they have that differs? So one, we know that they have different mass numbers. So different mass numbers. All right. Of course, then we know that the difference in mass numbers is as a result of the difference in their neutron numbers. So they have different neutron numbers. All right. Then third, of course, normally when you take two isotopes, what makes them different physically is their physical properties. You might end up having two isotopes, one looking like a liquid and the other being solid. So usually they have different physical properties. Different physical properties. So I believe that would bring us to the end of our class for today, isotopes. And please remember what isotopes are. You need to know what they are, and you should also be able to give examples of isotopes. You should be able to tell what resulted in the formation of isotopes. How different are isotopes from each other? How similar are they to each other? You need to know those concepts. So that brings us to the end of our class for today. Please, sharing is caring. Share the videos to your friends who might be struggling in integrated science or mathematics. Share, and if you've not already subscribed, subscribe to the channel. I need your subscription to be encouraged to do more of these videos. Take very good care of yourselves. Bye. We'll meet in the next class.